Have you ever encountered when you start the generator, it's running smoothly, but when you check the voltmeter, it reads 0. No voltage. No power. So what's really causing it? Let's troubleshoot that step by step. It is essential that all test instruments be regularly checked for safety, and any connection leads, probes or clips checked to ensure that they are suitable for the voltage levels being tested. Never attempt to test a live generator unless there is another competent person present who can switch off the power supply or shut down the engine in an emergency. Never expose live connections unless you have created a safe working area around you. Make sure you have made all other persons in the immediate area fully aware of what you are doing. First, don't assume the generator is already defective. Check the voltmeter itself. It could be connected incorrectly or it might be faulty. Use a separate multimeter and measure directly at the generator output terminals to confirm if there is really no voltage present. If the reading is still 0, inspect all wiring connections. But before conducting maintenance on the internal wirings, make sure the generator is not running. Disable the engine starting circuit before carrying out maintenance. Loose, broken, or corroded terminals can prevent voltage buildup. Check auxiliary terminals and all AVR connections. Tighten and clean them if necessary. A single loose wire can completely stop the excitation process. Check the resistance value of the exciter stator across these two leads with a multimeter. The reading should be approximately 18 to 30 ohms. Refer to Operation and Maintenance Manual for correct values. You should also check the insulation resistance of the exciter stator and main stator. Very low insulation resistance to ground can interfere with voltage buildup. Perform a Megger test and make sure the AVR is disconnected during testing. Minimum value to earth 1 megohm. High-voltage generators are capable of storing a dielectric charge in the main stator windings, following a high-voltage insulation test. Any testing of the main stator must be followed by a discharge to earth or ground for at least 1 minute. Do not attempt to touch the main output terminals until all residual charge has been discharged. Also check for winding faults such as open or short circuits by measuring resistance and comparing phase readings. Another common cause in most of the self-excited generators is the loss of residual magnetism, especially if the generator hasn't been used for a long time. Self-excited generators rely on a tiny amount of residual magnetism left in the laminated steel core of the exciter stator to generate an initial low voltage, which the AVR then boosts. If this faint field vanishes, the generator cannot start. Separately excited generators are much less likely to lose residual magnetism because they do not rely on the residual magnetism of the main field to build up voltage initially. I'll explain more details and how to troubleshoot the loss of residual magnetism in another video. Next, inspect the rotating rectifier assembly and diodes. A shorted surge suppressor or a faulty rectifier diode can stop excitation completely. Use the diode test function of your multimeter and replace any defective components. A multimeter will read between 0.4 and 0.7 volts on the diode scale with the positive lead on the anode and negative lead on the cathode. If you swap the leads it will read open. If it reads open in both directions or shorted in both directions then the diode needs to be replaced. If everything checks out and there's still no voltage, the AVR itself may be faulty. Try replacing it with a known good unit and test again. Lastly, make sure there is no load connected during startup because voltage may not build up under load. If your generator is running but shows 0 voltage, don't panic. Start with simple checks, follow the proper sequence, and diagnose step by step before replacing major parts.